G'day ladies and gentlemen, it is the Raging Ranga here, and welcome to your new section, Introduction to Differential Calculus. Ooh, don't that sound scary? Differential calculus. You know the word calculus over here? Think of calculus on your teeth. It actually comes from a Greek or Latin word which means hard. So yeah, look, it's not that tricky. Once you've introduced it and you understand what it's all about, you should start smashing it out pretty easily. We'll take it nice and slow. So what we'll be covering are rates of change, so the rates of things happening, instantaneous rates, finding gradient for a tangent, and then last of all, the derivative function, what a derivative function actually is. So without further ado, we're going to jump straight on into it. So an opening problem to get you thinking. You can have a read through this now. I can wait. And you finish reading, fantastic. So, Tina's cycling to school. You can see here on the graph, this is the distance she's travelled. So, the distance to her school, around about, what do we got there? 800 metres. About 800 metres to school. No, 900 metres to school, sorry. Amazing. I'm a maths teacher. So 900 metres to school, and that takes her about 200 seconds. You can see that here, she's travelling at a pretty constant speed, up until 100 seconds. How do we know that her speed's constant? Have a look, see what you reckon. What about her speed here? What's happening with her speed here? What would you say happening to her speed here? Is her speed increasing or decreasing here? Is her speed increasing or decreasing here? And what was Tina's speed during this first 100 seconds? You know, how could we find her speed during this time here? These are all things to think about. Again, there's a couple of things we could find as well. Between 100 and 200 seconds, we could find her average speed, which would just be the time here, which would be 100 seconds, and the distance she's travelled in this time, which would be 400 metres. That 400 metres divided by 100 seconds would get you her average speed. What about instantaneous speed? What's her speed at this exact moment here? What's her speed at this exact moment here? What's her speed at this exact moment here? These are all things that derivatives will help us to calculate. So first of all, let's talk about rates. Let's get our definitions down pat. Now a rate is a comparison between two quantities with different units. A rate is a comparison between two quantities with different units. And typically when we're talking about applications, this will be rates compared with times. So something compared against time. To time. So for example, the speed in this scenario up here would have been in meters per second. Meters per second. How many meters has she travelled compared with the time she's taken to travel that distance? So speed is the rate at which you cover a distance. Speed is the rate at which you cover a distance. Rates can also be different things. For example, Donald Bradman's average batting rate was 999.94 runs per innings. That's pretty insane. That's almost 100 runs every single time he was out on the field. That's nuts. So 99.9 runs per innings. There's a rate. Michael Jordan's average basketball scoring rate was 30.1 points per game. That's pretty insane. So again, points per game. There's your rate right there. Rangi's average typing rate is 63 words per minute. I've got no idea who Rangi is. Maybe it's Raging Ranga. I don't know. My long lost cousin. 63 words per minute. There's a rate right there. And errors per page. There's another rate right there. We can also talk about constant rates of change. Constant rates is where something increases the same amount each time. So it increases at a constant amount each time. Let's have a look here. We've got a swimming pool. It starts out empty, and over time, a certain amount of water is in that swimming pool. After 1 minute, it's got 15 litres in the swimming pool. Then after 2 minutes, there's 30 litres of water in the swimming pool, then 45, then 60, then 75. Each time, each minute, our pool is filling up by the same amount, 15 litres each minute, which means that we have a constant rate of change of 15 litres per minute. If you went and graphed each of these points, here, 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 and here, you could draw a nice straight, you could draw a nice straight line through all the dots. That's how you know it's a constant rate of change. So the pool has a constant rate of volume increase. The way we can actually calculate that increase from a graph is good old-fashioned y step over x step. Delta y over delta x. Again, remember delta just means change in. So we'd pick any y height. So for example, I might pick the y change between this point and this point. So it would be that height there. I then divide that amount by the x change. This is all pretty basic maths from back in the day. The slope of this line is the rate. In this case, the slope of this line is 15, which means the rate of volume change is 15 litres per minute, constant over this entire period. And that's it for this section, ladies and gentlemen. I would recommend that you write down this example as a note. This whole section here, write it down as a note, and then give these questions a crack. And we'll catch you next time. As always, don't forget, stay classy.